Hello guys, my name is Kumar Patel. Here me and my friend Achyut will demonstrate the Heartbleed attack in detail, like what Heartbleed is, who used it, how it works, and what are the impacts, and also the demo video of the Heartbleed attack. So, what is Heartbleed? Heartbleed is discovered in 2014. The Heartbleed is a serious vulnerability in the popular Open SSL secure socket layer cryptographic software library. This weakness allows stealing the information which is protected under normal conditions by the SSL secure socket layers encryption or TSL transport layer security encryption used to secure the internet. SSL or TSL provides communication security and privacy for applications such as web, email, instant messaging, and some virtual private networks. Open secure socket layer systems can communicate via the SSL encryption protocols. It was initially launched in 1998. Since then, OpenSSL has become one of the most widely used SSL implementations worldwide. Most web servers use OpenSSL to encrypt the web traffic. Actually, only 15 active developers were listed on the OpenSSL website during the Heartbleed attack, the majority of whom were volunteers. However, not all modifications to the OpenSSL software are created by these in 15 individuals. Following the discovery of Heartbleed flow, several significant IT firms pooled their funds to support increased efforts to secure OpenSSL and other open source software that forms the backbone of the internet. During a network connection, many routers on the internet lose the connection if they have idle status for too long. Thus, the heartbeat feature of SSL protocol proves useful here. This option enables a system at one end of the SSL to confirm that there is still a system on the other side. In this figure, we can see the example that how this function works actually. The potato in the example above is a message selected at random which serves as an acknowledgement. The number of characters make up the heartbeat message. The action on the server's part here is just to acknowledge the message received and repeat the message. The server's tendency to be overly trusting is exploited by the Heartbleed attack. The server automatically responds with a message of 6 characters after being informed that it has 5 characters. The server's credulity can be abused by an attacker. In this figure, we can observe that the secret word potato is not 150 characters in length. When the server replies the attacker, it doesn't check that the secret word is really 150 characters in length and replies with the original word potato plus the remaining characters. So, what are the remaining characters then? So, these are the contents of the system memory which may contain crucial information like username and passwords. From the example above, we can observe that sensitive details like user ID, password, and email are released to the customers. The impact is that any system that has vulnerable versions of OpenSSL can be exploited by any person. Here, OpenSSL 1.0.1 through 1.0.1g versions are vulnerable. Anyone which maliciously intend can read the contents of the memory of any server due to the heartbeat issue. Sensitive information that may be contained in the memory may be gained by the attacker. One of the major impacts of this attack is that no logs are generated for this attack. Thus, it becomes difficult to identify if any system was compromised. Now, my teammate Achyut will explain the demo of this Heartbleed attack.
Hi guys, my name is Achyut Shah and today I'll be walking you through the Heartbleed demo. We are leveraging the Seedlab VMs to carry out this attack. The VMs used in this case are the Seedlab Ubuntu 12.04 version machines. Although this attack can be carried out using just a single VM, but we are using two machines just to demonstrate how a remote server is attacked using Heartbleed. So these are the two machines in our case. One will be the victim machine or the server machine, and one will be the attacker machine. In case of the two machines, what we need to do is we need to enter the IP address of the victim machine in the host file of the attacker machine. So as we see that the highlighted is the IP of the victim machine and we just add it in the host file of the attacker machine. As we see that there are different files which are for different attacks from Seed Labs, but in this case we'll just change the IP address for this website which will be used to demonstrate the Heartbleed attack. Once changing the IP, just save the file and then we'll carry out with the next steps. We now go onto the Firefox browser. We go to the Heartbleed website, which is the dummy website or the dummy social media site, which will be used to carry out the attack. We log in as a legitimate user, which is admin in this case. The credentials for this can be found out in the Seed Labs lab manual. So once logging in successfully, we go to more members and we can add any one of them as a friend. So let's say we add Charlie as a friend. After adding Charlie as a friend, let's say we send him a message. Let's say this is our private message. So once after sending the message, now to carry out the attack, we need the attack file. We get the attack file from the Seed Labs website. This is the attack file that we need. For the purpose of the video, I have already downloaded the attack file in the attacker machine. To just carry out the attack, all we need to do is just run the file with the URL of the website. So this is the result that we get after running the attack file. We see here that the Heartbleed attack was successful. We also see that we can get the profile of the Charlie. This is the cookie that we get, and this is the username and the password that we use to log in to add Charlie. As you can see that the username and the password match with what we entered and is in the Seed Labs manual. Now this is what we got on the first try, but to get more data we need to run this attack again and again to get more data, as most of the contents are in the memory of the system. So let's try running it again. As we see, we are getting more information like token, then again the password. Let's see if we can get the private message that we sent to Charlie. So after running third or fourth time, we see that this is the private message that we sent to Charlie. Let's try to send one more message. Now let's get back to the attacker machine and try to run the attack file again. We are still getting the old message. See, after running multiple times, we see that the test2 message is retrieved. So in this attack, we need to run it multiple times in order to get the data. So we observe that the flaw lies in the heartbeat request, which Saral explained in the previous slides. So if the server doesn't check the length of the response of the original message sent, the response from the server will bleed or leak the data from the memory. However, we don't know where the X starts. It may start after the username, password, or after the message. This is why we have to run it multiple times to get the data from the server. There are other options such as the payload length. So maybe let's try with it. Let's play around with the payload length option to run the attack. We see that once we enter the length, we get some of the data. Let's try decreasing the length. Okay, so from this we observe that the boundary value here is 22. So at below the boundary value, the query length will receive the responses packet, but without attaching the extra data. So we see that the attack was successful, but it did not return any extra data. In this attack, we notice that there are no logs created as we are just reading the contents of the memory that too from a remote machine. So if no logs are created, it becomes difficult to detect an attack, right? And we imagine that how difficult it would have been for the organizations during that time when this vulnerability was discovered, just to know that if they were attacked or affected by this attack, if the data was disclosed or breached. How we can fix this vulnerability? Just update the OpenSSL versions. The newer versions in the OpenSSL are already patched and it becomes difficult to carry out this exploit. So guys, this is it from my side. I'll pass on the microphone to Saral.
So, how to fix this? As long as the vulnerable version of OpenSSL is in use, it can be abused. Fixed OpenSSL has been released and now it has to be deployed. Operating system vendors and distribution. Appliance vendors, independent software vendors must adopt the fix and notify their users. Service providers and users have to install the fix as it becomes available for the operating systems, networks, appliances, and software they use. So, these are the references that we have used to make the presentation. Thank you guys.